Mary's rectangular garden covers an area of 155 square feet and is enclosed by a total of 51 feet of fence. Find the dimensions of the garden. Let's draw a picture. Why not? Okay, there's Mary's garden. She has one flower. That's it. Good job, Mary. We know this area in here is 155 square feet. And we know all the way around would be 51 feet. We have two formulas at work. What two formulas are we working with here? And perimeter. So for funsies, let's call this L. Let's call this W. So give me an equation for area for this problem. L times W. And for us, we know the area to be 155. Give me an equation for the perimeter. Good. All right, so we've had farmer-style problems before. This one's a little bit different. The way they were set up before was start with the equation where you know a number and solve for a variable. Well, we know a number for both equations. So basically, we're trying to find two numbers whose product is 155, and 2 times the individual number's sum is 51. So we can solve for one of the variables in either equation and use that expression for the other variable. To make things nicer, let's solve for a letter in the perimeter equation. So which one do you want to solve for, L or W? L it is. So if we solve for L, we'll subtract 2W from both sides. Then we'll divide by 2. Is everyone okay with that? So now instead of the instead of the L in the area equation, we could write 51 halves minus W times W equals 155. Oh, that got squishy. Sorry about that. If you distribute that W through, you would get negative W squared. I'm rearranging the terms. Plus 51 halves W equals 155. What type of equation is this? Quadratic. If only we learned 4 different ways of solving a quadratic equation in one section. We did. So you would please pick one of those 4 ways and solve for W. If you want a hint, I would suggest rewriting it so that the leading coefficient's positive. Ding, stop, hammer time. It actually does factor. Ten times 15.5 is 155. Negative 10 minus 15.5 is negative 25.5, which is 51 over 2. Oh, I'm so sorry. I could have told you that it factored. And guilt over. So, setting each factor to 0, you would get W to be 10, or W to be 15 and a half. Now, this is not typical for a word problem. What usually happens when you have a word problem is you get something that is clearly not a possible answer. These are both possible answers for W. However, if W was 10, the corresponding length would actually be 15.5. I'm not going to fit it. I'll just put it there. Because since we have this formula right here, putting in 10 for W gives you L to be 15.5. Or putting in 15.5 for W gives you L to be 10. The first pair is probably the more acceptable one just because length is usually longer than width. But technically, they're both correct. And they both say the exact same thing.